So we continue. So that was just the concern that was raised by one of your colleagues about the absolute values. Can we move on? So we said that to evaluate this, we are discussing 3A1, we are discussing the absolute value function. Okay, so we went as far as getting this 2x minus 1, then is squared. Okay, let me just do this properly. We said we write 2x minus 1 square, then square root. By doing this, we're just applying the definition of the absolute value function. Then squaring on both sides gives us 2x minus 1, then squared greater than x minus 1, then squared. So this is the stage at which the network had to cut. So when we do some expansion, we expand, we get 4x squared minus 4x plus 1 greater than x squared minus 2x plus 1. Collecting like terms, we have 3x squared minus 2x greater than 0. And so factoring out x here, we factor out the x, we get 3x minus 2 greater than 0. The critical values, we say the critical values are x equals 0 and x equals 2 over 3. These were the critical values that we obtained. Then we now went to drawing the table. Since we are solving an inequality, to solve an inequality, you need to come up with some table and test some regions. Okay, so this leads us into, we have the number line here, and we're getting two numbers 0 and 2 over 3. So these two numbers divides the number line into 3 regions. This region, and the last one. Okay, so we said we are going to test each region to see whether it is the wanted region. So we can do that by picking some value in each interval. In this interval, we can pick maybe x to be -1. In the mid interval, we can pick x to be 0.5. In the last interval, we can pick x to be 1. The factors, we have x, then 3x minus 2, and finally the product of the two factors, x by 3x minus 2. Okay. So now, let us now test. In this interval, that is some interval, in the interval which is on the left of 0, we have negative numbers this side, and we have picked one value, one integer for the testing case. So if we substitute this value on x, we observe that the result is negative. When you substitute 0.5 on x, the result will be positive. When you substitute +1 on x, the result will be positive. So we have negative, positive, positive. We also do the same in the other factor. Okay, so here we are saying it's negative, here it's positive, there it is also positive. Then we test when we put -1 here, on the second factor 3x minus 2, we get negative. Then when we put 0.5, we also get negative. Then when we put 1, we're getting positive. Then the product of the factors, the signs of the factors, negative by negative, gives us positive here. So we have positive. Then the product of the two signs, negative by positive, gives us negative, and so we have negative here. Then positive by positive, we have positive. So now we get back to the sign of the inequality. Here, the sign is strictly greater than. When it is a strict inequality, we don't include the bounds. The bounds are not part of the solution set, or rather the domain that you're going to get. Okay? So now, since we have a greater than here, meaning that the product of the two factors, this and this, must be positive. Greater than means positive, right? Greater than 0 means positive. Meaning that this is positive. So where is the product positive? It is in this and the last interval. So our regions of interest are this and that. So we can write the solution set as negative infinite to 0. Then union 2/3 to positive infinity. So this is the solution set required. Any question on this? Then should we move on to the next? Okay. We now go to 3A part 2. We are solving the inequality 1/3 minus 2/x squared less than 5/3x. So we have 1/3 minus 2/x squared. Then introducing the active inverse of what is on the right, introducing the active inverse. So we have minus 5/3x less than 0. And so we can get the lowest common multiple of the denominators. So we have 3 into 3x squared. It is x squared. X squared times 1 will get x squared. So we write x squared here. Then x squared into 3x squared, it's 3. That 3 multiplies the 2, we get minus 6. And for the last factor, we have minus 5x. So since we expert at factorizing quadratic equations, when we factorize, we get, okay, let's do that. Maybe others may be stuck. Eh? So we have x squared minus 6 minus 5x, which you can write in standard form, x squared minus 5x minus 6. So the product is -6, right? The product is -6. What are the factors? The two numbers, when you multiply, you get -6. When you add, you get -5. So the factors are 1 and -6. So when you add the two, you get -5. When you multiply the 2, you get the product, which is -6. And so we have x squared minus 6x plus x minus 6. So factorizing here, we can factor out some x, and so we have x, then x minus 6. Here we factor out a 1, so that we have x minus 6. So we have x plus 1, x minus 6. So that's how we factorize. So we have x minus 6 and x plus 1. over 3x squared less than 0. We can multiply by 3 on both sides. X minus 1 plus 1, then x minus 6 over 3x squared less than 0. We multiply also by 3 here. So 3 and this, the 2 are dividing to give us a 1. 1 multiplies this. Here, multiplication by 0 doesn't change anything. So we get x plus 1, x minus 6 over x squared less than 0. So some common mistakes I was able to observe when I was marking your script. Others were making this mistake. It was very much common, where they multiply by this on both sides. Yeah. Do not do some premature division or multiplication. So you just leave this as a variable. Quite well, we understand that this, because of the square, the result is positive, but there may be some cases where you may not know whether the result here on the geometry is either negative or positive. So when you multiply on both sides, you may not be sure whether the inequality is changing or facing changing the direction to face the other way around or not. So that's why we don't tamper with the variables. So now the next thing that we have to do is to come up with a table. First, we get the critical values. So from this stage, we come here, critical values. X equals -1, x is equal to 6. So these are the two critical values that we have that allows us to draw the table. Okay. So now let us draw the table. We have a number line here. And then you're getting two values, -1 and 6. How many critical values did you get, by the way? Okay, let's get to the previous screen. Okay. So now there is another critical value that we have omitted here. X must not be 0, because when x is 0, this fraction won't exist. When x is 0, this fraction will not exist because we don't divide by 0. So 0 is also a critical value. So we're having 3 critical values. So we now have the number line negative being divided into some regions following the 3 critical values, 0 and 6. So you have like this. So your number line is being divided into how many regions? 1, 2, 3, 4, into 4 regions. So we're going to test the wanted region in each interval. Here, we can pick x to be -2. Here, we can pick x to be -0.5. Here, we can pick x to be x to be 1. Here you can pick x to be 7. So we have the factors. Let's begin with this. So because of squaring, whatever value we put here, whether it is negative or positive, because of squaring, the result will be positive. So we have that this is positive in all the regions. That is positive. We go to the other factor, x plus 1. When you substitute some value, when you substitute -2 there, the result will be negative here. When you substitute -½ it will be positive here. When you substitute 1, the result will be positive here. When you substitute 7 on x, the result will be positive. So we get negative, positive, positive, positive. Then we can go to the other factor, x minus 6. We have positive, negative, negative, and positive. We substitute those values that we have picked. And finally, the quotient, x plus 1, x minus 6 over x squared. Okay, so you have this by this is negative, divided by that, we're getting negative here. We have this by this by this, we're getting negative. By these two factors are multiplying, as we can see here. No wonder I'm saying this times that, because the two factors are multiplying on the numerator here. So this by that, we're getting negative divided by positive, we still get negative here. Then this by that, it's negative divided by that, we get to negative. Then this by that, we get positive divided by that, we get positive. So the signs are positive here, negative, negative, and finally positive. So now, you observe that these are critical values. They are not part of the solution set, right? They're not part of the solution set. So what is the wanted region? We are interested in the region where this is negative, because from the previous screen, this was less than 0. Meaning that this has to be negative. So this is negative in the two intervals, the two regions. So from this to that and that to that. Since 0 is a critical value, it's not part of the solution set. So we write the solution set to be -1, 0, union 0 to 6. So this is the required solution. Okay. To proceed, let's go to the next screen. So 3B. So we are on binomial now, 1 plus C. One plus x over k to the power n. So k is a positive integer. K is a positive integer. And then we're told the coefficient of x and x squared are equal. So then we drive what they want. We show that 2k equals n minus 1. So to show this, let us first expand expand this binomially, we have 1 plus x over k to the power n. So expanding this using binomial theorem, we have the first term. Let me just try to remind you of the theorem. We know that when we have a plus b to the power n, this gives us a to the power n plus n, a to the power n minus 1, then b plus c n minus 1 over 2 factorial a to the power n minus 2, then b squared, plus and so on and so forth. So that's the binomial theorem. So now in our case, our a is 1. Our a is 1, and our b is x over k. So we just make some substitutions in the theorem. So making substitutions, we get 1, since our a is 1, then our n is not known, our a is 1, our b is x over k. B at this stage as the power 1, then at the next stage, we have n minus 1 over 2 factorial, then we have 1 to the power, whatever power, it still simplifies to 1. Then our b is x over k to the power 2. Plus, since this is this goes on and on, we say plus dot, because there are so many terms that we have left. We've not written all the terms. So simplifying this gives us a 1 here. Then at this stage, 1 by n, it's n, x to the power 1, it's x, k to the power 1, it's k. So we get plus n x over k, plus here also we have a product, 2 factorial, we know it's 2. So this by 1 is just this, x squared and k squared. So we have n minus 1, x squared over 2 k squared. But then we are told the coefficient of this term here, the coefficient of the second term, the coefficient of x and x squared, x here, x has a coefficient n over k, and x squared has the coefficient n minus, in bracket n minus 1 over 2k squared. So we're told that these coefficients are equal. What does this imply? We're just going to equate the two. Since the two coefficients are equal here, the coefficient at this stage is n over k. So write k equals. Then the coefficient of x squared at this stage is this. That's what we're going to write. So we have n minus 1 over 2k squared. Since the coefficients are equal, when we do some cross multiplication here, we do some cross multiplication, we get 2k squared n equals n k n minus 1. Then we can divide on both sides by n. So we have n, we divide by n. Okay, let us do that at the second stage. We have 2k squared n, we divide by n, even nk, n minus 1. We are dividing by n at this stage. So we have this and that dividing out, this and this dividing out, so that we remain with 2k squared equals k n minus 1. Here also there's something that is common. We can divide out by k. So dividing out by k, we have 2k squared. We're dividing out by k. We have k equal k by in bracket n minus 1. Since we're dividing by k, this reduces into 2k equals n minus 1. This is because these two are dividing, and one will divide the remaining with a k there. So we have driven what they wanted as, hence shown. Hence shown. Okay, any question on this part? Okay, so we can proceed to the next question. The other part demands us to show (3b2). So if n is 7, determine the value of k. So we have shown already that 2k is equal to n minus 1. Now, since n has been given to be, n has been given to be 7, others can just put 7, and so we have 2k equals 7 minus 1, giving us 2k equals 6, so that k is equal to 3. Okay, we proceed to the next question. Question 3. 3C. So question 3C, we have x over y minus y squared over 3x squared to the power 8. And then, and you mute yourself. Find the term containing x squared. We want to find the term with x squared over y squared in the expansion of this. So we do not know the position of that term. One may decide to expand this using the binomial theorem, and then one would be able to identify some term which will contain this, or as they expand. When they expand, then they simplify. As they begin simplifying, they will be able to arrive at this. They'll be able to see the term that has this. And then on the other hand, one may also use this method. We're going to use, we say let the term with x squared over y squared be the r plus 1 of the term. Then we have any combination R So then we have the A part, which is x over y to the power 8 minus r. By the way, we are using this formula. We're using n choose r, then a to the power n minus r, b to the r. So since our n is known, it's 8, our r is not known. So our a is known, it's x over y to the power 8 minus r. Then our b is y squared over 3x squared to the power r. So just by writing this stage, we'd have scored a mark. Then the next step, we can write 8 combination R. We have x to the power 8 minus r over y to the power 8 minus r. Since this and this being inside the bracket implies this is the power for x, this is also for the power of o, this is also the power of y. So I've just distributed this power to x and y. So we can do the same even here. We can do the distribution. So we can split the terms here. We can pull out y, distribute the r, we have 2r over x to the power 2r, then by 1 over 3 to the power r. Okay, the next step, we have 8 choose r, then we have 1 over 3 to the power r. At this stage, 1 to the power r is still 1, 3 to the power r, this is what we have here. Then we come to the variables. To the variables also, we can simplify using the laws of indices. This and this, this and this, the base is the same. And so when the bases are the same, we're dividing, we subtract the powers. So we're going to apply that. We can also apply the laws of indices on this. Okay. So we have x to the power 8 minus r and x to the power negative 2r over 1, then times we have y to the power 2r times y to the power negative 8 minus r. Here, this also over 1. So what we have done here is that we have simplified this and that. Because this and this are dividing and the base is the same. So this can be written as it is 1 over this. So when we take this up, it means the power becomes negative. This is what we have done here. And the y to the power 2r, this is the 1. So we move on and write 8, 1 over 8 combination r, then 1 over 3 to the power r. When we simplify this part here, since we are multiplying and the bases are the same, we add the powers by the laws of indices. So we have x to the power 8 minus r minus 2r by, we also simplify here since we are multiplying and the bases are the same, we add the powers. So we have y 2r minus 8 plus r. Okay. So this is over 1 and this is over 1. Let's come here. So we have 8 combination r, 1 over okay, 1 over 3 to the power r. Then we have x to the power, when we simplify here, we have 8 minus r minus 2r gives minus 3r. So the power now becomes 8 minus 3r over 1. Similarly, to simplify here, we get this and that gives us 3r. So we have y to the power negative 8 plus 3r. This is also over 1. Okay. Then we proceed to have 8 combination r, 1 over 3 to the r. Then we have x to the power 8 minus 3r times. We can factor out on the y here, the power of y, we can factor out the negative so that we have 8 minus 3r over 1. So you know by the laws of indices, we have 1 over 3 to the r. Using the laws of indices here, we are going to simplify the power of y. Since the power of y is negative at this stage, so we can write 1 over y to the power, then the power will be positive. The power is negative here, so when you write 1 over y, then the same power, the power will be written positive now. So we have 1 over y to the power 8 minus 3r. So we have 8, choose r, 1 over 3 to the power r. At this stage, we have this multiplied by 1, we still get the